We're here in the glasshouse at Hermitage Research Facility, and this is the crossing glasshouse for the National Mungbean Improvement Program. So this is really the start of the breeding program, and where we're making new combinations of varieties and lines. Our real focus is foliar disease resistance, so halo blight and tan spot, and to a lesser extent powdery mildew. So they're really some of the barriers to reliability in the Mungbean industry, and they've been a focus of our work for 10 years or so. And we released varieties like Crystal and II-AU. We've seen really big uptake in those varieties, but really they've been stepwise improvements in terms of disease resistance. They offer stepwise improvements and maybe repackaging of the best available resistance. But with newer material that we've been evaluating and we've been testing, we're now going to see really big jumps in disease resistance. They're really going to deliver in the paddock. 10 years ago, the Mungbean industry was about 30,000 tonnes. Since the release of Crystal, we've grown that to about 60 or 70,000 tonnes, and that's a combination of varieties and management and I guess industry support. And with the recent Mungbean strategic planning and their strategic plan for the next 5 years, they've set an industry target of 170,000 tonnes production. And varieties are a really important part of that, both in terms of yield potential disease resistance. Just in May this year we released a new small seeded variety that's called Celera II-AU, and that's the first variety that's been bred in Australia with resistance for halo blight, and that's really a benefit of the germplasm and the genetic diversity that we're working with. It's a small niche market, but really it gives us more breeding tools and allows us to, I guess, to strengthen the depth of the Mungbean industry. So working with small seeded Mungbeans, and also we work with black gram, which is a related species Munga. We've found some really interesting disease resistance to both halo blight and tan spot. So we're working with that in black gram and the scope to make interspecific crosses to bring that resistance across the species into our crystal type Mungbeans. But there's also scope we're looking at releasing a variety to replace Riga. Riga is an old variety that fits a niche for a black gram for a very small market, but it has very poor agronomy and it has limited yield potential, and it can be susceptible to some diseases, so there's scope for us to release an improved variety. So we're currently looking at a line that's about 10% higher yielding. The black gram line we've just started pure seed production, so that might be available in 2017. I guess the importance of disease resistance in Mungbeans especially is that we're dealing with bacterial diseases, so we have no means of in-crop control. We have no chemicals that we control, so genetic resistance is really the most useful tool that we've got. I guess Mungbean breeding has been very successful in terms of the yield gains that we've delivered and the growth that's sort of supported in the industry. What I'm really mindful of is that we want to stay ahead of the yield plateau. What I'd really like to develop is our scientific understanding of the genetics behind our disease resistance, so we can breed better varieties, we can breed them faster and more easily. Also, I'm interested that we look into the physiology of Mungbeans. We can deliver big yield gains, like 20% from the old variety Emerald to Crystal, but we really need to understand what the yield components of that yield gain come from. In the last 3 years, the Mungbean breeding program, we've imported 400 lines from the World Vegetable Centre. I guess I see that as our resource. That's the library of material that we'll be going to for the next 10 years. That's our working material. And the technologies like genomics and genetics that we're now incorporating into the program, that's going to allow us to get much more information and much more value out of that material and apply it to our breeding program. And as we've done in the past with our halo blight resistance, we'll incorporate that into adaptive backgrounds, and that's going to deliver new traits like drought resistance and heat stress, all those traits that are going to improve the reliability of production in Australia.